Okay, guys, greetings. This is just a walkthrough of the Unit 7 and 9 practice test. Let's take a peek at this. Given a triangle ABC where C is 20 degrees, A is 5, and B is 12. First thing I'm going to do is draw the triangle ABC. It says angle C is 20 degrees. Side A, that's over here, is 5. Side B is 12. That's here. Now, right now, just looking ahead for a moment, I noticed that determine the area of the triangle. That's using that formula where the area is equal to 1/2 times a side times a side. Here, let me scoot that up. Times a side times another side times the sine of the angle in between. So going a little bit out of order here, but I just looked at this problem. It's gonna deal with that. So I'm gonna find that area right now. Let me think. My calculator's in degrees. So 1/2 times 5 times 12 times the sine of 20 degrees, 10.26-ish. So it doesn't give me any unit. Oh, it does meters. So 10.26 square meters. Okay, now I need to find this. I don't have a pair of anything, so I've got to use the law of cosines. So I'm going to find side C, because that way I can get a pair. So I know to do that, I do C squared equals A squared plus B squared minus 2 times AB times the cosine of 20. So I'm going to set that up. C squared equals 5 squared plus 12 squared minus 2 times 5 times 12 times the cosine of 20. Sorry, I kind of smushed that in. It goes from there to there. Type that in a calculator. 5 squared plus 12 squared minus 2 times 5 times 12 times the cosine of 20. And I get 56.2 something-ish. So that's C squared. So C squared is 52.2 something-ish. So I want to find C, so I'm going to take the square root of that thing. So the square root of that answer gives me 7.49. So I'm going to go 7.5. 7.5. Okay, so 7.5. Now I can use the law of sines on this because I have a pair right there, right? So I'm going to go 7.5 over the sine of 20, and that's going to equal... okay, I'm gonna wait. This right here should be the biggest side, so I want to save that for last. So I'm gonna find this one first right here. So 5 over the sine of A, take a cross product, that times that divided by 7.5. So 5 times the sine of 20, all divided by 7.5, and that gives me this thing. Now that's equal to the sine of A. So I need to take the inverse sine of that thing, and that gives me 13.2. So A is 13.2 degrees. Okay, so 13.2 degrees. Now I did that because if this had an obtuse angle, it's going to be across from the 12. So I wanted to make sure I solve that last. Remember, when you're doing this, either go from small to big or big to small, but you never want to do the big one in between. So I've got this 13.2 degrees plus the 20 degrees. So I've got that plus 20. And if I do 180 minus that answer, that's going to give me my third angle, 146.8. So that's angle B, 146.8. Okay, there we go. Okay, to the nearest thousandth, solve this triangle. Yuck. I notice it gives me all sides. Okay, so I've got 10, 16, and 8. And 10 is A, so there's A. 16 is B, so that's B. That's C. So if I use the law of cosines here, because I can't use law of sines. I don't know an angle. I'm going to find angle B first. I'm going to go from big to small. So I'm going to go 16 squared equals 10 squared plus the 8 squared minus 2 times 10 times 8 times the cosine of, that's opposite B. Remember, this side is opposite of that angle, and then these are the other two sides. Same here. Okay, so I'm actually going to subtract 10 squared and 8 squared right now. So minus 10 squared minus 10 squared minus 8 squared minus 8 squared. Okay, so in my calculator, I'm going to go 16 squared minus 10 squared minus 8 squared, and that gives me 92. So I've got 92 equals this whole thing. Negative 2 times 10 is negative 20. Negative 20 times 8, excuse me, is a negative 160. Cosine B. And if I divide by negative 160, I get 92 over negative 160 equals cosine B. Now I need to take the inverse cosine of that. So 92 divided by negative 160 gives me that. And then if I take the inverse cosine of that number, I get 125. Okay, so B is equal to 125 degrees. B equals 125. But now I've got a pair here, so I can use the law of sines because that's a lot easier than this stuff. So law of sines says 16 over the sine of 125 is equal to, and I want to find the next biggest side first, 10. Let's go 10 over the sine of angle A. Take a cross product, divide by that 16, and then looking ahead, well, okay, let me just catch up with myself. 10 times the sine of 125 all over 16 equals this number. Now that number, see, it's not equal to A, but it's equal to the sine of A. So I need to take the inverse sine of that number, and I get 30.8. Or, I don't even care if you go to 31. As long as I see the work where it came from, I'm not really concerned about the rounding. I know it says to the nearest thousandth, but yeah, you know what? I'm going to go 30.8 because that sounds good. A is 30.8. So there's 30.8 degrees. Okay, now I know two angles, 125 and 30.8. So I can add that to the 125. And then I can go 180 minus that number, and I get 24.2. So C is 24.2 degrees. And there are all three of my angles. Okay, cool. Okay, now let's look at this last story problem here. Two scuba divers are 20 meters apart below the surface of the water. Okay, so I've got person A and person B. They're 20 meters apart. They both spot a shark that is below them. So shark's below here. I'm going to go, there's my shark. The angle of depression from diver 1 to the shark is 47 degrees. So that's there because it's the angle that I have to depress from there, right? Okay. And the angle of depression from diver 2 to the shark is 40 degrees. So that's the angle he has to look down. So there's 47 to 40. And if you don't like the fact that I made it kind of tilty, just tilt your paper, and now it's kind of a nice, perfect straight line. But really, it's just those angles. Okay. To the nearest tenth, how far each of the divers from the shark? So I've got to find B and A. Well, I can actually use the law of sines, can't I? Yeah, because see, check this. 47 and 40, if I go 180 minus 47 and minus 40, I get 93. So this is a 93, sorry, that's a 93 degree angle. 93. And if I go 20 over the sine of 93, that's going to equal this other pair. Let's find b first. B over the sine of 40. Take the cross product, multiply these, divide by that, and I end up getting 20 times the sine of 40 degrees all over the sine of 93. That gets me, oh, math error. Okay, I forgot the parentheses there. Cool. 12.9, let's call it. So B, that's 12.9. I can do the exact same thing. 20 over the sine of 93 equals A over the sine of 47. Okay, so, and I can take the cross product there, multiply these two, divide by that, and so I get 20 times the sine of, heck, all I got to do is go change that 40 to 47, right? Yeah, 20 sine of 47 divided by sine of 93, and bingo, 14.6. And these are both meters. Okay, so there's that. Okay, now remember on the test, there's going to be one of those problems. Something. Okay, cool. Let's look at this. Here's my formulas that I've been given. Write out and evaluate the sum. Write out and evaluate. So this says go from the second term to the sixth term of that. So if I put a 2 in there, I get 2 minus 1 is 1. 2 to the power of 3, 2 times 2 times 2 is 8. Plus, if I put a 3 in there, 3 minus 1 is 2. 3 to the power of 3 is 27. If I put a 4 in there, 2, 3, 4. 4 minus 1 is 3. 4 cubed is 64. And if you don't know those right off the top of your head, just type it in the calculator. 5 minus 1 is 4, and 5 cubed, 5 times 5 times 5 is 125, plus 6 minus 1 is 5, all over 6 cubed. I'm pretty darn sure that's 216. 6 to the power of 3, yep, 216. Okay, so that's what it means by write out the sum. Just write them out, and then add them all together. So 1/8 plus 2 27ths plus 3 64ths plus 4 125ths plus 5 2/16ths, and I get 0.3011. That's it. Cool. So you should know, remember, that it tells you what number to start with. I started by putting a 2 in there, and then what number to stop with, 6. So I go put in a 2, put in a 3, put in a 4, put in a 5, put in a 6 into this formula, and then add up all what you get. Okay, there you go. Now, this gives me the sum. It says write using sigma notation. So sigma notation and start at 1. Always start at 1. And I got to think about this. This is 1, -5, -9. What's happening here? Is it subtracting every time? Going down by 4, down by 4? Yeah, it's going down 4 every time. That means it's an arithmetic. Well, an arithmetic sequence, remember, this is one you need to memorize. It's the difference times n plus the 0th term. Well, the difference is -4. -4n plus the 0th term would be if I go up this way. So -1 plus 4, that's going to be 3, because 3 would be 4 above -1. Okay, now I need to figure out how many terms there are. 2 ways to do that. I can set this formula equal to 29, or what I'm going to do is I'm just going to go -1 minus 4 makes a -5. Okay, minus 4 equals, that's -9. That's the 3rd term, 4th term, 5th term, 6th term, 7th term, 8th term. Oh, 8th term, 1 to 8. I didn't take me that far. Okay, the way I usually decide whether I'm going to set this equal to that term and solve it, or whether I'm just going to do what I did on the calculator, just hit enter, enter, enter until I get it, is I look at that and I say, it's not going to be that many terms from here to here. If I think it's going to be a lot of terms where I might, where I might lose count, I'll probably set the formula equal. Okay. which would mean you're taking -4n plus 3, setting it equal to -29, and solving that, and eventually you'll get n equals 8. That doesn't seem right. Oh no, if I subtract 3, okay, yeah, that works, that works. Okay, determine if this is arithmetic or geometric. Remember, arithmetic is adding or subtracting, geometric's multiplying, and then evaluate this on using one of the above formulas. So, using one of the above formulas, I'm told that I can't just write out the terms like here. I've got to use a formula. Okay, so -2 plus 12 plus 72. This is going up by 14, and this is going a lot. This is geometric, because it's not, I can see it's not adding the same amount every time, because it's a lot farther from 12 to 72 than 2 to 12. -2 to 12. So I think, what am I multiplying by? The ratio I find by taking this divided by this. 12 divided by -2 is -6. Okay? The formula for geometric says it's the first term, so that's -2 times 1 minus the ratio, which is -6. I'm just looking up this formula, to the power of n, all over 1 minus the ratio. Now I know I skipped a spot, because I got to figure out how many terms there are from here to here. Well, yuck. With geometric, I'm always just going to do it like this, because it's a whole lot easier. -2 times -6 makes 12, times a -6 makes -72. That's the third term. Fourth term, fifth term, sixth term. Oh, there it is, sixth term. To the sixth term. Okay, now I just type that in. I'm going to type it in exactly like it looks. So big fraction, -2, parenthesis 1, minus parenthesis, -6, close the parenthesis, to the power of 6, close the parenthesis, all over 1, minus, in parentheses, -6. What I've typed is what I wrote down, and that gives me 13,330. Cool. Okay, cool. Now this one, 1 to 18 of 2k plus 10. Well, 2k plus 10 looks like the arithmetic formula that I had up earlier there, right? You see it? Difference times n plus the 0th term. So this is cool. So I know it's arithmetic, which means I'm going to use this formula. So n over 2, well, n's 18. So 18 over 2 times the first term plus the last term. Well, the first term I find by putting a 1 in here. 2 times 1 is 2, plus 10 is 12, plus, and then I put an 18 in there to find the last term. 2 times 18 is 36. 36 plus 10 is 46. Cool. Now I just type that in my calculator. 18 over 2 times 12 plus 46 gives me 522. 522. And that's it. Cool. Okay. That is the end of page 1. On to page 2.